Good evening, everyone. This is the process assignment for online course on foundation design by Shreemalika Baruah. That's a brief introduction. This video is made by myself, Shreemalika Baruah, of Jorhat Engineering College as a part of the final assignment of foundation design course from Skyfi Labs. To begin with, let us start with the basics of what is a foundation. We all know that foundation is the lowest part of a structure which provides a base for the superstructure and transmit the loads, live loads, dead loads on the structure and the weight of the superstructure itself to the soil below. That's the role of a foundation. That's what we can see here. And then to the classification of foundations, there is shallow foundation, deep foundation. For shallow foundation, we have the isolated footing, the combined footing, strap footing, mat and raft footing. For deep foundation, we have fight foundation, well and caisson foundation. In our previous videos in the Skyfi Labs, we have already been well versed with what are the different classification of foundation. But since the project is related to the mat or the raft foundation, so let us directly go on to the mat or raft foundation. What is it? What is a mat or raft foundation? Well, it is a foundation system in which essentially the entire building is placed on a large continuous footing. It's basically a concrete slab that supports many columns. There are many columns in it, and it can be used for silos, chimneys, large machinery, for huge loads, right? We use the mat or raft foundation. When the soil has low bearing capacity, right? So we'll come to know when do we use the foundation, and it is basically made up of a flat concrete slab. We'll come to know about it when we design it in the software. Reinforced with steel, reinforcements to be used, which carries the downward loads of the individual columns of walls. The basic principle is to dissipate the load to a larger area. When do we use it? When the spread footings cover over 50% of the foundation area because of large column loads, when the soil is soft with a low bearing capacity, when the hydrostatic uplift resistance is needed, when there is low soil bearing capacity. So these are the various conditions where we need the mat or the raft foundation. And this is the basic, you can say, a real life example of mat or raft foundation. This is, since it will carry a huge load, we are preferring a raft foundation. And then moving over to our problem for today's project that we have been given, the problem statement. This is a raft foundation comprising of 16 columns of the safe bearing capacity 300 kN per meter square with allowable settlements of 1 centimeter. With an interval of 6 meters between the columns. And this is the problem statements comprising of the loads, dead and live, the materials M40 HYSD 500, and its dimension comprising of 500 into 500 millimeter and 600 into 600 millimeter. Let us do some initial calculations. First, we'll find out the subgrade modulus. We all know that subgrade modulus is safe bearing capacity divided by allowable settlement, that is 300 kN per meter square by 1 centimeter. We get 3 into 10 to the power 4 kN per meter cube. We will be requiring this when we will define the soil subgrade properties. We will be needing this soil subgrade modulus. Again, when we will be using the design strips, we will need the use of the width. So we'll be calculating the width. We know that the column strip width is L by 4, the lesser of the two. Here L1 and L2 both are same, both are 18. You already saw it. Let me show you once again. 666, both are 18, so 18 by 4 is 4.5. We'll be using we'll consider it approximate to 4. So we will be using the strip width as 4 meter, and that is something we used it for the, you can see the 18 and 18 dimension is for the slab, but for the mat footing slab we will be extending it by 2 meter by 2 meter later onwards. So this is the thing, actually it will be 22 meter and for the entire mat footing, right? So this is the problem statement. This is what we need to do. This is what we are assigned to do. Now I'll show you with my let us start with the project, right? This is the safe software. New model. Please bear with me, it's kind of a very old computer, so it keeps on. So okay, this is IS 456 design code, design preferences. We'll be using the minimum slab covers of 50 mm and 50, and we'll be choosing a preferred bar size of 22 mm, right? Okay. And the units, currently metric units already selected. If you want, you can select it once again. It's default, it's fine. We'll be using an initial model of grid because there is no template for it. We have to create it ourselves, right? So we'll be using the grid only. Now, we already saw in the problem statement it was 18 into 18 meter. If we choose an interval of columns of 1 meter each, so how many grid lines would we need? If we have 18 meter and a spacing of 1 meter each, so how many columns do we need? 1 into 18 plus 1, 19. So 19 grid lines in X direction and 19 grid lines in Y direction. So we'll be using 19 because there's always one extra for the grid lines. We'll come to know about it when we'll draw the foundation, or you can see the entire base, right? So this is the spacing 1 meter and the grid lines, number of grid lines is 19. Done. Okay, so this is the interface we'll be given. Now we have defined the interface. We have to come now to define the required properties, right? Firstly, the materials. We need the M40 and HYSD 500, so we'll be adding a new material. That is, first we'll be using M40. It's a concrete grade and its weight per unit weight per unit volume. These are the standard ones, so you can find it in the internet. Modulus, electricity 1 2 7. Okay, so that's the M40. We'll add another material that is for the HYSD 500. HYSD 500. That's a rebar, right? It's 77. It's 500 and this is 545. Okay, so this is the thing. We've defined the two materials. Now we will define the slab properties. We'll add the new property for that will be for the mat footing. Right? We'll use the slab material already defined, M40, and type is mat, and let us consider thickness of 500. We can change it later on when we will carry out the analysis. We will not give any stiff outs here because we will already define the column properties. Here, even though there is 16 columns, we have already seen, but there is two types of columns only. Even though there is 16 columns, two types only, 500 and 600 dimensions. So we will add two columns. That is column 1. Let me give it name as column 500. The material is M40, and this is just add advertisements. Okay, so this is M40 and kind of you can see it's the M40, and let us give us the 500 and 500. Alright, so yeah, so that's the thing, and 500 so okay, add new property, column 600, M40, 600. Okay, you can check it out if you are like kind of you can always cross check, right? If you think that you have missed out something, it's alright, it's fine. Okay, so these are the two columns. Okay, so we have defined the materials, slab properties, the columns, and now we will go into the soil subgrade properties. So we already calculated the subgrade modulus, if you remember, or let me just show you. is 3 into 10 to the power 4. So if you write in exponential terms, it will be 3e4, right? So let us modify, and we can see it's 3e, right? So let us change it to 3e4, solid 1, everything is fine. Okay, soil subgrade properties, and then we will define the load patterns. It's dead, live, fine, load cases, linearly static, it's fine, load combinations. All right, so there is no combinations, we'll add 2 combinations. We always know that there is, if you have the basic concepts of structural engineering, we all know that there is ultimate strength, service loads, ultimate load, right? We learned in RCC. So ultimate load, we have the scale factor of 1.5, and in service load we have the scale factor of 1. So here I'm giving 1.5. So what does it suggest? Ultimate load. All right. Okay, sorry, this is for live, right? Dead and live. 1.5, 1.5. We're selecting for ultimate strength. Okay, everything is fine, right? Okay. Add new combination. Combination 2 is again dead and live, and this time what will be the scale factor? Yes, it will be 1. And since it is 1, it will be service load, it cannot be ultimate load. Okay, that's done. Combination 1, combination 2, fine. Okay, done. So we have assigned patterns, combinations, now everything is done. We have defined every properties, right? What we will do is that now, what are we missing? We are missing the interface, right? Where is the slab? We need the entire interface for it. So we will now draw the slab, because we don't have the slab, right? Draw slab and areas. So okay, so we have defined the property of mat footing. It's already selected, it's fine. Let me pan it, right? Yeah, okay, for better view. Grid point here to here to here to here, and always, yes, right click outside, it's done. Press escape to undo all selections. Escape, always be ready. Fine. Okay, so this is the thing done. Now what is that? This is what we learned that time. This is a 18 into 18 perfect slab. But what we discussed at that time, that we needed it for the mat footing. We'll take an extension for 22 people. So we need to extend 2 by 2, right? What we'll do is that we need to extend it. So we'll edit it, and we'll first select it. Yes, one area and 4 edges selected at the bottom. Always confirm it at the bottom left. Edit it. We will go for the edit areas. Okay, I get it, it's fine. It's expand or shrink areas. So what did I did? It's 2 meters, right? 2000 m. Sorry, expand and shrink, it's fun. Okay, so this is the thing. So we expanded it, right? That's what I did. Expanded it. So we are like just now having what we discussed it to be. This is what we are having, right? So we are going as it is, we discussed. Okay, done. Now we have made the interface. We have to now draw the, what's left now? The columns, right? So let us draw the columns. Draw the columns. Fine. We have defined 2 columns of 500 millimeter dimensions and 600 mm. So to begin with 500 mm. Okay, let me show you the picture once. It'll be much better. Visits. Yeah. So this is a 500 mm. So you can see this is here 600 column 10 and column 11 has 600 mm, 6 and 7 has 600 mm. So 10, 11, 6, 7. So the middle 4 columns have 600 mm dimensions and the outer ones have the 500 mm dimensions. So what we will do is that first we will select the 500 mm, create the outer columns, then we'll select 600 mm, create the inner columns. It will save our time, right? Okay. So it's 500 is selected, but see, keep in mind this property below, we do not need a column below, it's none. Always above, it's 500, height below, it's 0, height above, let us consider 2 meter, 2. Okay, now what we will do is that, let us start making. So I'll again once show you. It's 6 meter intervals around. We'll now make the outside columns since they are 500 mm, so of 6 meter intervals. See, this is 1. Okay, 1 2 3 4. Okay, it's being shown, right? So see, 6 meter 2. So the thing is that we are just making the outer columns since they are of 500 and we have selected the column of 500 dimensions. It will save us time, right? Otherwise we have to kind of keep on changing it. Done. Press right click outside. Done. Change it to 600. The middle fours, right? 6 and 6 and 6 and 6, right click outside. So this is the entire slab is done, entire thing is done. Now what we'll do is that we close it, press escape to undo anything. Now what we'll do is that we have to now draw the design strips, right? Let us go for design strips. Okay, draw, sorry, I mean to define. Draw design strips. And A, strip layer A of strip layer means design strips along the x-axis. B strip layer means design strip along the y-axis. So along x-axis A, and we've already carried out the calculations for the width. We have found out the calculations as 4.5 meter. If you like kind of approximate, it will be 4 meter. We are like kind of selecting 4 meter. So this will be 4 4 4 4, right? Done. So 4 4 4 4 A, that's along x-axis. Let us start making it. So we need to keep into consideration. I'm just closing this because I need this. That it always we might have this thing of like not being accurate in selecting the point, but with practice, with due practice, it does come. So it's better you zoom in, pan in to get the accurate selection, right? Otherwise, it might create some discrepancy in results. So this is the second one. I'm not good in this, but it's fine. You have to just pan in and kind of try, because when you do the same thing at a wider perspective, it creates some mistakes, right? So zoom in to reduce any errors, or you can say to reduce or to increase the accuracy. Okay, so this is the fourth one. It really took me a practice of 2 times you can say, to kind of be able with this. Okay, see, I'm still not being so efficient in it. Right click outside, find all the 4 lines done parallel to x-axis. These are the strip layer A, but we need B, so don't keep on continuing. These are A. We'll change it, right? But since I closed it, I'll again open this up, draw design strips, change to B, close it, and then start drawing. And start drawing it. Don't forget to press right click outside, because otherwise, you know, you will accidentally end up creating a design strip which we do not need, and which would create enormous results, and you know, it will lead to your wastage of time to kind of undo everything and delete it. It's fine. Right click, so done. These are the strips in the y direction, strip layer B. So let me press escape. Fine. So this is the thing done. Now we have defined and drawn whatever we need. Now what we have to do is that to assign it, right? Only defining won't work. Press escape once again. You can see it's ready. Select on any area inside the footing. Select it. You can see at the bottom left corner always. You can use it for verify. Then we'll go to assign, support data, soil properties, soil 1. Okay, done. It's done. Okay. And then next thing we have to do is assign loads. But the loads, let me show you once again. But the loads is different. See, all the columns have different loads. So what we can do is that we have to assign loads one by one. You can't help it. But the thing is that first let us assign the loads for the 500 ones, then for the 600 dimension ones, right? This is gonna be a very tedious and lengthy process, but we can't help it. We have to do it. So we'll select the first one. We go assign loads data, point loads, dead loads. That is this is the first. What is this? This is the column 1. So the first dead load for the column 1 is 1850. It's 1850 according to the question. And live load. Okay, so I will do it later. Let load. And here the dimension for column 1 is 500. Okay. Again we will assign. That was only the dead load. Assign the live load. So now sorry, 7 and 7.6. So the thing is that we need not to change it, right? So again to change it to 600 will take time. So let us do the 500 ones. Okay, this is for the first column. Again, in this way, this is column C1. So in this we have to go and continuing doing for the column. This is for C1. This is for C2. For 7 C2. Okay, see, I accidentally selected design strip, right? You see it green. Please press escape when you accidentally select things like this. Press it escape, right? You don't want things to mess up. Sometimes it does happen. It's good that it happened right now. I could like kind of point you out the thing. It's a very long process. It takes time, but it's fine. It's all right. You can't help it, right? You have to assign the loads to each of them. Dead loads, live loads. It takes time, but it's worth it. The results you'll get in the end. It's just beautiful. It would really make you fall in love with structural engineering or in geotech engineering. In short terms, engineering. I'm still at the go. It takes your time and patience, but it's all right. This is the dead load. And live load. Again dead load. Okay, this is the last of the 500 dimension columns. It's making me excited. This is the dead load, and then we'll assign the live loads, and the live loads is 769.8. So this is for the 500 dimension columns. Now we'll go on to the 600 dimension columns. These are just 4. It's fine. Let me first change the major change out here. The 600, right? So the 600 is dead load. Okay, I try to click at the center, right? Otherwise you go on selecting the design strips. Sometimes, okay, we might have mistakes, right? What I want to show right now is that now I'm confused and maybe I'm mistakenly typed somewhere else. What you can do is that when you have some doubts, right click on the middle of the column, check the loads, right? So 497725, so okay, so 4977.2, so live load should have been something else. I did a mistake. So what you got to do, okay, to learn that, I'll show you how to learn that, is that click on that again where you committed the mistake, go to assign, just like how we're doing right now, load. So my mistake was in the mistake was at the live load, right? Go to live load, replace existing load, 2579.8. Okay, so now let us check it. See, it's all right? Okay, so sometimes you might have a mistake. It's very possible for you to commit a mistake, just like I did right now. I was doing everything fine, but this is what it happened. When you sometimes, I'm now excited that this entire thing of selecting and giving things might end, and sometimes things might come up, but it's all right. It's all about learning from mistakes. So this is the assigning. So let me assign here dead loads, and so since I did a mistake to that at that time, let me check, is it all right? See, since I was having a mistake, so that affects all. That's what I'm saying. Sometimes you need to be very much focused at things, but it's all right. I will make the change. So see, I created a mistake in a dead load. What you do is I create del. What's the thing you need is right, 5154.6. What you do is it replace existing nodes, alright, and then it's all just the same. You do not need to panic, okay? Mistakes might happen. It's all about learning from it, right? See, it's all okay. So finally, without hesitation, I'm coming to the last load data, creating so much mistakes at the journey. The dead load 1044.8, 1044.8. And the live load, dealing with this excitement, this really creating mistakes. Okay, so this is the dead load and 1044.8 and the live load. Okay, I'll just show you something. This thing. Days on the 51, yeah, 1.3. It's all right. Sometimes okay, it's done. I hope it's done with no mistakes. Always try to check it, right? If there's anything mistake, you have to repeat everything, and that's heartbreaking. It's really heartbreaking. 2644. It's alright. I'm just checking the 600 ones before. Click at the center and 54414, 2797, 4977, 2579. It's okay. I guess rest should be okay. You can check it if you want. I'm just checking the first few. 797. Always right click at the center and you can check it. What is it, all right or wrong? And if it is wrong, I just said you what to do. Just go there and just do the same. All you need to do is replace the existing nodes, right? So sometimes you do commit mistakes, it's all right, but you just need to be calm and like make the needed corrections for it, right? So it's done. I guess rest are all right, but it's okay. I think everything should be okay, but you know, I'm sometimes into this mess of considering things to be okay and then again kind of thinking that no, let me give a last check. Fine, let me give a last check. It's better to be safe than to be sorry. It's alright. If you have a jot down of the question, you even you can have a look at the things when being verified. It's alright, you can verify the things. Takes time, but it's worth it. I guarantee you the results are worth it, and it's okay. I'm done with the last one, and yeah. Okay, so this is the thing. We are done with assigning the loads. Okay, we have done the assigned loads and everything. Okay. Now assign the loads. Fine, good. Now we'll go to assign the rebar material. What we'll do is that right click. Okay. Done. Right click on any footing area. Design tab, rebar material should be changed to HYSD 500. It will automatically impact the columns. And also for design strip, you need, this is the column strip, right? You need to change the rebar material for all the design strips too. When you're making a selection, there's this yellow light blinking, right? You can see at the back. Yeah, so that is a verification that it's fine. Okay, so we have set the rebar material fine. Okay, so we have set it for all the X and Y direction strips. What we'll do is that now we'll try to save it. For saving it, we always press run analysis and we'll give a very proper name to it. I hope it doesn't hang. Okay, fine. So what I will do is that let me save it, give a proper footing to it. Suppose mat footing. Give a name to your file and save it. Okay, it's done. Now what we'll do is that the analysis is being done, but you can see, okay, now it's done. Yes, so this is our analysis. This is the analysis is done. What you can see is that we can see displacements value of the dead loads in millimeters. These are the color coding. Through this you can see the displacements corresponding to every area. What are the displacements, right? Okay, so now for punching shear, let us go run analysis and design. It's done. We'll go to display punching shear. So we can see the values are all greater than 1. We all know that the punching shear should be less than 1 to pass the design check, but since it is greater than 1, what we'll do now, we'll unlock it. It will delete only the analysis. Don't worry, it won't delete the software. It's okay. What we'll do is that we'll again define and we will change the thickness. Okay, I said at the beginning this might be changed, so 500 is not working, let us change to 900, right? Okay, now just repeat the step, run analysis and design, keep on waiting for things to load, and then again display the punching sheet design. See, there's still few columns where the it's thing, but it's you can again find, you have to continue, you need to have less than 0 in all the columns. So let me again modify, let me increase, like from 1900 let me increase to 1200. Okay, run analysis and design. You need to kind of adjust this is all about, this is what structural engineering is all about. You need to adjust it for the key values, right? So this is the thing, sorry, display punching shear design. Yes, everything is less than 1, so this is past the punching shear test, it's good. Now so we have now completed with the design of our math foundation. So now what is left is all about interpreting the results of our analysis and design. So to interpret results, now only we need help of the display button. Let's display. Let us go with the strip forces. So the load case, firstly, suppose considering dead load moments of layer A, that is x-axis, show values on diagram, apply. So you can see the different moments about x-axis. If you need both axes, you can select waves B, or you can select load combinations. Combination 1 is ultimate load. So these are the different ways through which you can kind of see the different results according to it. Then we can go for the suppose show slab design, right? What you can do is that we will take the impose minimum reinforcement. We will know what is the minimum reinforcement to be used. We'll apply and close. So we can see what are the minimum reinforcement to be used at the top and the bottom, right? And design accordingly. Then we will go to display and show slab forces and stresses. What we can do is that we can select different load combinations. Suppose combination 1, I've selected suppose for the maximum shear stress, right? Moments, sorry, max is moment, maximum moments, and you can see the different maximum moments, or you can see the for shear, maximum shear. So for different parameters you can get your different results. Then we can say show crack widths. We will know about the different crack widths for the different load cases. For the load combinations, suppose bottom crack width, apply. See, these are the different thing. Here each color determines the width of crack. The color codes you can see at the right, it's of the range of 10 to the power minus 2, is very negligible, it's okay for us. Or you can go for the slab top face, apply. You can see different crack widths in millimeter, right? Okay, so this is all about displaying. Now to generate reports, if you want to generate detailing reports, go to the run detailing. You marked all, okay. Component views, slab views. See, we can, this is a plan, right? This is a rebar plan. Then you can rebar tables. We will know about the different bars used, okay? Different bars being used out here. What's the different bars, the different quantities of bars, everything is being used out here. Then rebar schedule, mark, type of bars, these are different things used. Then bill of quantities, the amount to be used. These are very important when you're designing. These are the prerequisites for it. And you can see again for the slab use, let us check it, mat 1, rebar plan. So you can see here the rebar layout, the entire rebar layout of the mat. See, it's the entire layer of top and bottom. Or separately you can see the top rebar plan, or you can the bottom rebar plans. It's a very important feature. Then you can come to the section 1, section 2. These are like rebar plan at elevation section at both the directions, you can see, right? These are important. Then you can see layer A, layer B, the reinforcement area distribution you can see. layer A, layer B. It's nice. Drawing sheets, cover sheets. This is something you can, at the end, this is a kind of a declaration that it's being generated, and this is the the final things to general notes, right? Sheet numbers, so people can take a print out of it, right? You can give your things out here and you can have a print out and different things. So this is the entire, you can see the detailing reports based on your based on your requirements, based on the engineer's requirements. They'll carry out the printout of it and your work is done. So this is what was all about my project. It's about creating a foundation design. I was creating for a tall building. So basically it was the entire layouts that was being taken. This layout was taken from a software, ETAB software, and from there we created this. This is a real life scenario. This is something which can be used for tall buildings. Mat or ref foundations being used. So this is what my project is, and I hope you liked it. And with this, I, Shreemalika Baruah, conclude with my presentation, my project assignment for the online course on foundation design. I thank Skyfi Labs for being so articulate and conceptualizing the things in such a better way. It made me learn and get a deeper perspective of such a industrial grade software. It's just sitting at home and making good use of the lockdown. Thank you to Skyfi Labs, and I hope this remains beneficial to all the people who can get to view it. Thank you.